Hello guys, welcome back to my channel enginiusmechtech. Today we are starting our chapter number 19 and lecture number 4, bulk deformation processes. Bulk deformation processes in metal working includes rolling. There may be other deformation processes related to rolling, forging, and some processes related to forging, extrusion, and wire and bar drying. Bulk deformation is basically metal forming operation which causes significant shape change by deformation in metal parts, whose initial form is bulk rather than sheet, such as you may be a billet, like a square bar, a rectangular bar. Its starting forms may be cylindrical bars and billets, rectangular billets and slabs, and maybe other similar shapes. Bulk deformation process also sometimes improve the mechanical properties of material and some also other properties like shape and anything else. These processes work by stressing the metal sufficiently to cause plastic flow into desired shape. It may be sometimes cold processes, warm processes, hot working processes, cold working, etc. Importance of bulk deformation. When performed as hot working, significant shape change can be accomplished. For significant and major shape change, we perform hot working. For the strength to be increased during shape change, we performed a cold working because the cold working increased the hardness and strength of the material. Little, if we want no waste or little waste, some bulk deformation processes are near net shapes and some are net shaped. There are four basic bulk deformation processes. Rolling. In the rolling, slab or plate is squeezed between two opposing rolls and get into desired shape. In forging, work is squeezed and shaped between opposite dies. It's like pressing, something is imposing on it. Extrusion is basically work is squeezed through a die opening, thereby taking the shape of the opening, just like a nozzle. Wire and bar drawing, the diameter of wire or bar is reduced by pulling it through a die opening of a low diameter. Basic bulk deformation process this is the visualization of these processes. Rolling is like two opposing rolls and it's passing through it. Forging is pressing in a die. We are getting the desired shape. This is extrusion. The force is acting upon the circular ram or rectangular ram, and the work is getting from here. And this is the basically drawing process. Rolling is deformation process in which work thickness is reduced by compressive forces exerted by two opposing rolls. Just as you have seen in the picture, the rotating rolls perform two main functions. Pull the work into the gap between them by friction between the work part. Due to the friction of the rolls, the work part is moving from them, and simultaneously, at the same time, the work is squeezed and reduce the cross-section area. Type of rollings. By the geometry of work, there are types. Some types, flat rolling, used to reduce the thickness of rectangular cross section. It's the simple wording. And in the shape rolling, a square cross section is formed into shapes such as an I-beam, like I-beams and girder type. By temperature of work, hot rolling, the most common due to the large amount of deformation required in shaping. In cold rolling, produces finished sheet and plate stock. Rolling is a very capital intensive process as massive piece of equipment called rolling mills are required to perform it. The high investment cost required the mills to be used for large production of standard items such as sheets and plates. It's costly and expensive process. Just as we seen in the rolling processes, it is some kind of example, the steel rolling practice. The work starts out as a cast steel ingot. The steel is in the form of ingot that is just solidified by casting. While it is still hot, the ingot is placed in a furnace where it remains for many hours until it has reached a uniform temperature throughout. That the inner part of the steel ingot must be reached at the same temperature as outside. For the steel, the temperature is around 1200 degrees centigrades. The heating operation is called soaking and furnace is called soaking pits. The ingot is then rolled into one of the three intermediate products called bloom, slab or billet. Bloom has cross-section area of 150 mm or higher. Slab has rectangular cross-section area of width 20 mm or more and thickness 40 mm or more. Billet is square cross-section of 40 mm or higher. These intermediate shapes are subsequently rolled into the product shape. These are the flat and shape rolling processes. This is the slab, this is billet, this is bloom. This is the process of slab, hot strip, scalp plate, and these are the pipes. This is for the core strips, this is for steel plates. Billet is hot rolled bars into the circular bars, rods. These are all the applications you may, as you have to see some videos on YouTube regarding these processes for your more understanding. This is the bloom. This is converted into structural shape like I-beams. The rails slab is converted into plates, sheets, and coils. Billet is converted into bars and rods. This is actually the mechanism of the flat rolling and its analysis. When the roll speed it is represented by VR, and that area, the contact length is represented by L. This is kind of some arc that is represented by theta. Theta is the angle of the circle that is in contact there. It is the angular length. R is the roll radius and P is the roll pressure. That is the roll applying on the sheet. This is the initial thickness T naught and this is the final thickness T after forming deformation. This is initial velocity and this is final velocity that is sometimes higher than the initial. Now some terminologies. Draft. Draft is basically amount of thickness that is reduced. That is initial thickness minus the final thickness. And here D is the draft, T naught is starting thickness and TF is the final thickness. Reduction is equal to draft expressed as a fraction of starting stock thickness. R is equal to D by T naught, where R is known as reduction. This is another view of flat rolling. This is the workpiece. This area has V naught and this is the VF. This is the angle theta of the length of arc that is in contact with the material, and there are some thickness and some other terminologies. This is the roll gap, this is entry zone and this is the exit zone. As you can see, this is the illustration of flat rolling process, friction forces acting upon it and the roll forces and the torque acting upon rolls, the width of the strips, and these are some terminologies. How to reduce the force or power in rolling. Force or power to roll a strip of a given width and work material can be reduced by any of the following. We may use hot rolling rather than cold rolling because when we increase the temperature of material, its ductility increases. As ductility increases, it's easy to deform. Then strength and strain hardening of the work material is reduced, so YF is equal to K e power n. Another is reciprocal. We may reduce the draft in the each press. We must not have to reduce the thickness in just one go. We must divide the process into different steps. L is equal to R into T naught minus TF is reduced. Using similar roll radius to reduce the force, we must use the same roller radius, L is equal to R, and using a lower rolling speed, we must have slow process and to reduce the power. Now next is the shape rolling. In shape rolling, the work is deformed into a contoured cross section rather than a flat rectangular piece, accomplished by passing work through the rolls that have the reverse of desired shape. That if we want some D-like shape, we have opposite of the D on the rolls. Gradual deformation through several rolls, and the process is stepped into different phases to achieve the final cross section is achieved by designing a specific roll pass design. Products include construction shape of such as I-beams, L-beams, and U-channels, rails for railroad tracks, and round and square part of the rods. This is visualization of shape rolling. As for the rails, this is the shape of the rollers, inverted shape of the rollers for the rails. This is for another type of rolling, and this is the fourth type of rolls. In stage 4, this is using edge rolling, step 5 and the 6. We are getting the desired and final shape. It depends upon what kind of product we need. This is some kind of rolling processes. It is hot material. And this is another rolling mill, a general view of rolling mill. Rolling mills equipment is massive and expensive. Various rolling mill configurations are available to deal with the variety of application and technical problems in the rolling mills. Rolling mill configurations too high 3 high, 4 high, cluster mills and tandem mills. You may go through it. This is 2 high rolling mill. This is 3 high rolling mill, one with the go, one with the reverse. And this is 4 high rolling mills. There are some kind of this mechanism to reduce the power. This is the cluster mill in which multiple backing rolls allow even smaller rolls diameter. Various configuration for rolling mills cluster. Backing rolling arrangements. This is a kind of huge rolling sets for the single sheet. This is tandem mill in which one is reducing some diameter, then second is reducing some diameter, and third is reducing some diameter. You can see another type of the thickness is written here. Other deformation processes include related to rolling are thread rolling, gear rolling, ring rolling, and roll piercing of Mannesmann mill. Thread rolling is basically making of threads-like structures on the piece. Just as this is the starting workpiece, put it in the die, and this is the final desired part. Ring rolling have applications balls and roller bearing races, steel tires for railroads, etc. Advantages: material savings, ideal grain orientation, strengthening through cold working. This is the ring rolling. This is the start of the ring. And this is the final in which the diameter of the ring is increased but thickness is decreased. Roll piercing is the specialized hot working process for making seamless thick walled tubes. Process is based on principle when a solid cylinder part is compressed on its circumference, high tensile pressure are developed at its center. If compression is high enough, an internal crack is formed. Compressive stresses on the cylindrical billet are applied by two rolls whose axes are oriented at slight angles, so the rotation tends to pull the billet through the rolls. A mandrel is used to control the size and finish of the hole. This is basically the deformation, crack, and this is the pressing, and now the rolls are getting the desired shape. This is the mandrel. Forging is the deformation process in which work is compressed between two dies, using either impact or gradual pressure to form the part. Oldest of the metal forming operation components are engine crankshaft. In addition, basic metals industries use forging to establish basic form of large components that are subsequently machined into final shape and size. It is normally used. Classification of forging operation. Cold forging and hot forging. Hot or warm forging most common due to significant deformation, and we need to reduce the strength and increase ductility of the work material for changing it into desired shape. But in cold forging, the advantage includes that there is high strength that result in the form of strain hardening when we force by the means of force we change the shape. Impact and press forging. Forge hammer applies an impact load and forge press applies the gradual pressure. Just like this is the forging hammer, and if we press both of our hand and like this is acting like a press. Types of forging dies. The distinction is based on the degree to which the flow of work material is constrained by the dies. Open die forging, work is compressed between two flat dies. Impression die forging, die surface contain a cavity or impression that is imparted on the work part. That's similar in the case of previous die-like structures. Flashless forging, work part is completely constrained in a die and no extra excess of material or flash is wasted or produced. This is simply an open die forging. Force is acting upon it and the workpiece is changing its shape. This is the impression die forging. This is the shape and the desired shape. And this is the flashless forging. No material is waste. This is the pushing force. This is similarly the excessive theory. You may go through it. That's some kind of formula. Open die forging with no friction. If no friction occurs between the work and the die, so that radial flow is uniform throughout the work part, height and true strain is given by E is the strain is equal to natural log of h naught by the h, where h naught is starting height and h is at the some point. Force required to continue the compression at any given height is given by F is equal to yielding force into area. Open die forging, friction between work and die surface constrain lateral work flow of work, resulting in barreling effect. This is some factors that include F is equal to Kf, Yf, A, where Kf is the forging shape factor given by equation. Kf is equal to 1 plus 0.4 micro d divided by h. Micro is the friction force and h is some height and d is the diameter. This is the diameter. This is kind of example. You may get through it for the practice. Impression die and closed die forging. Compression of work part by dies with inverse of desired part shape. Fly ash is formed by metal that flow beyond die cavity into small gaps between die plates. And this is some kind of theory, not important. That's like a good picture or visualization. This is starting billet. When the force is applied on it, it's deformed into the desired shape. And when the more force is acting upon it, the flash is come into both sides. We later remove it. This is some kind of practice. There are some advantages compared to machining from solid stock. Higher production rate and die forging, etc. Conservation of metal. There is less waste, greater strength, and favorable grain orientation in the metal. There may be some limitations that includes not it is not capable of close tolerance. There may be more gap. Machining often required to achieve accuracies and features needed such as holes, threads, and mating surfaces with fit with other components that must be required after the forging. Now we are going on flashless forging. Compression of work in punch and die tooling whose cavity does allow for flash. Starting work part volume must equal to die cavity volume within very close tolerance. That the volume of the part must be inside the die cavity. Process control more demanding than impression die forging. Best suited to part geometries that are simple and symmetrical, often classified as precision forging processes. This is the flashless forging. This is the billet. Force is implied on it. The deformation occur, and this is the desired finished part. Forging hammers may be known as drop hammers. Apply an impact load against work. This is actually the impact hammering. Gravity drop hammers. There are two types. Gravity drop hammers that impacts energy from falling weight of an heavy ram. In this gravity effects. And the power drop hammers accelerate the ram by pressurizing air or stream. Disadvantages of impact energy that it is transmitted to the anvil, that is heavy metal anvil, into the floor of the building that may damage our building if we are on some kind of floor. Most commonly used impression die forging. This is drop forging hammer fed by conveyor or heating units, the right of the scene. This is the diagram, and this is the head of the head containing cylinder. This is the piston rod. This is the frame. This is the ram, heavy ram. This is the anvil. This is the drop hammer. Forging presses apply gradual pressure to accomplish the compression operation. Types: mechanical presses convert rotation of the drive motor into the linear motion of the ram using gear systems and some kind of another systems. But hydraulic piston actuates the ram, and some kind of screw presses in which the screw mechanism drives the ram. This is impression die forging. Flash gutter, that is removal of the flash. This is some kind of rib, web, fillet, etc. etc. Upsetting and heading. Forging process used to form heads on nails, bolts, and similar hardware products. More parts produced by upsetting than any other forging operation. This is for the production of more parts performed on the cold, warm, and hot on machines called headers and formers. Wire or boss stock is fed into the machine, a head end is headed, then piece is cut into the length. For the bolts and screws, thread rolling is then used after to form the threads. This is the punch, this is the stop, this is gripping die. In the second, it goes up and the force is applied on it. This is desired shape. This is similarly the shape for the nuts, bolts. Swagging accomplished by rotating dies that hammer a workpiece radially inward to taper it as the piece is fed into the dies. It is used to reduce diameter of the tube or the solid rod stock. It's manual. Sometimes we require it to control the shape and the size of internal diameter of tabular parts. It must be cleared here that when the work is pushed in the die, this is the actually the final diameter, and the final diameter is reduced. And as you can see in this area, that the the work is rotating, and in this direction the feed is given, and in this direction the rolling rotation is given. Trimming, cutting operation to remove the flesh from work part in the impression die forging. It's usually done after the work is still hot, so separation must be easy. Trimming can also be done by alternative methods such as grinding and sieving. This is the cutting edges and force is applied and the flesh is removed. Extrusion. Compression forming process in which the work material is forced to flow through the die opening to produce a desired cross-sectional shape, just as this, or any kind. The process is similar to squeezing toothpaste from the toothpaste tube. Just as in or washrooms, we paste daily, brush our teeth daily. Just as we exclude the paste from the tube, this is extrusion. In general, extrusion is used to produce long parts of uniform cross sections. There are two basic types of extrusions: direct extrusion and indirect extrusions. This is direct extrusion, in which the ram is forcing some kind of billet or material, and there are dies that is converting it into the desired and final product. It is also known as forward extrusion. This is also called forward extrusion. As ram approaches die opening, a small portion of billet remains that cannot be forced through die opening. This extra portion called the butt. The butt must be separated from extruded product by cutting it just beyond the die exit. Starting billet cross section usually round, but the final shape is determined by the die opening. This is some direct extrusion to perform hollow shape. This is the ram. We may convert into circular, rectangular, C shape, G shape, etc. Anyone. This is the indirect extrusion. In this, the desired shape is actually in the ram. When we push, the material is flow back into the ram, hollow ram, and sometimes it's outside the ram. That depends upon condition what thing we are making. Also known as backward extrusion and reverse extrusion. Limitation of indirect extrusion are imposed by the low rigidity of hollow ram and difficulty in supporting extruded product as it exits. General advantages of extrusion that it's maybe variety of shape possible, especially in hot extrusion. Grain structure and strength enhanced in cold and warm extrusion. Close tolerances are possible, especially in cold extrusion, because in hot extrusion there may be some expansions due to heat, and some operation little or no waste of material. Hot extrusion preheating of billet and above its recrystallization temperature. Strength reduced, ductility increased, so it's easy to deform. But in closed extrusion, used to produce discrete parts. Extrusion ratio is given by, it's also known as reduction ratio. It is defined as R of X is equal to A naught divided by AF, where Rx is the extrusion ratio, A naught is cross-sectional area of the starting billet, and AF is the final cross-sectional area of the extruded section, applied to both direct and indirect extrusion. This is the die angle. We must not increase die angle to some major extent and not minor extent. If the friction angle, if the alpha is high, this is ram force we need high, but at some time this is the optimum friction, optimum angle. But as we increase more angle, it must increase the friction. So we must select the optimum die angle. Low die angle, surface area is large, leading to increased friction. Large die angle, more turbulence in material flow during reduction. So ram force is increased. Optimum angle depends upon the work material, billet temperature, and lubrication. This is not important. This is the complex extruded heat sink for heat sink section. We must see on the bikes and engines this type of shape. Extrusion press is the device that is used for extrusion, wire and bar drying. Cross section of the bar rod or wire is reduced by pulling it through the die opening. It's not the pushing force, but now it's the pulling force. It is similar to extrusion, but in this same thing that the work is pulled through the die. In drawing, it is pushed. Uh, in in the extrusion, it is pushed, but in drawing, it's pulled. This is now force is acting upon here. We pull it. Initial diameter is high. After the forming, it's low. This is the draw die. Now in this area reduction is in drawing is given by R is equal to A naught, the initial area, minus AF, the final area divided by A naught. This is the same thing. Wire drawing and bar drawing are the two different things. In the what is the difference? In the bar drawing, large diameter bar and rod stock. In wire drawing, the small diameter stock. The wire size down to 0.03 mm. It's very small. This may be possible. Although the mechanics are the same, the methods, equipments, and even terminologies are different. Drawing practice usually deformed as cold working, most frequently used for round cross sections. Product from the drawing is that we get are in the wire drawing, electrical wires, wire stock for fences, coat hangers, and shopping carts. You must see wires. And rod stock for nails, screws, rivets, and springs also get. In bar stock, metal bars for machining, forging, and other processing. Bar drawing accomplished as a single draft operation. The stock is pulled through one die opening. Beginning of stock has large diameter, it's straight cylinder. The necessity is a batch type operation. It's a batch type operation. This is hydraulic cylinder that is pulling some kinds of wires. It's not okay. We go through it. Continuous drawing machines consist of multiple draw dies. They are typically 4 to 12, separated by accumulating drums. Each drum is known as capstan, provide a proper force to draw wire. Each die provide a small reduction, so easily the desired shape is achieved in a series. This is like some reduction areas. Features of draw die: interregion funnels lubricant into the dies to prevent friction. Approach cone-shaped regions where drawing occurs. Bearing surface determines the final stock size. Back reliefs are the angle and its angle. Back relief half angle of about 30 degree. Die materials, tool steels are cemented carbides. This is the entry region. This is approach. This is bearing surface, and this is back relief. And this is actually the approach angle. Preparation of the work for the wire drawing: annealing to increase ductility, cleaning to prevent damage through the work surface, and pointing to reduce diameter of starting and allowing insertion through the draw die. So this is actually the part 1. The next area, the next of the remaining chapter, it's not complete. Half of chapter is covered in the next videos because this video is getting too large. So dear viewers, see you in the next video. Till then, take care.